All right, so today we are going to be looking at lesson 22.3. We are going to be continuing our study with our trig ratios. So we looked in the previous lesson at our trig ratios, and I told you it was vital that you picked a mnemonic device and that you learned it. So what I recommend doing is starting by writing out your trig ratios before you even look at what problem you have. So we know that the sine is the opposite over the hypotenuse. The cosine is the adjacent over hypotenuse, and the tangent is the opposite over adjacent. So whatever mnemonic device you use, you should be getting those ratios. So now let's look here. They want us to find the value of y. So they tell us here to use the sine of 41. So we're using the 41-degree angle. Typically, they're not going to tell you which angle you have to use, but on this one, they're trying to help you a little bit. So if you look at the 41 degrees, where is your hypotenuse? Well, it's the 100. So then once you have your hypotenuse, where is your adjacent? It is right next to the 41. So it's this side PR, this vertical side. And then that leaves the y for the opposite. Once you've done that, which of the adjacent, opposite, or hypotenuse do you have either a variable or a number for? Well, the opposite has a y, and the hypotenuse has a 100. Which one of your trig ratios uses hypotenuse and opposite? The sine. So we are going to be using the sine because it is opposite over hypotenuse. So they told us sine of 41. So we should have already known that we wanted to use opposite and hypotenuse, but normally they don't give it to you. So sine of 41 is opposite y over hypotenuse 100. So first thing you do now, you need to find the sine of 41. So if you use your calculator, sine of 41 is 0.656. And that is equal to y over 100. Now this from here is an algebra problem. You're trying to solve for y. You are dividing it by 100. So you need to do the reciprocal, which is to multiply by 100. And so on the left side, you're also going to multiply by 100. And so if you do 100 times 0.656, you end up with the fact that y equals 65.66. So that would be how you find y there. Looking at part B. This time they're telling us to use the 28. And they tell us specifically to use cosine. But let's not know that. Let's pretend like we don't know that. So looking at the 28 degrees, my hypotenuse is the y. Adjacent to the 28 is the 18. And then opposite it is this mn. Well, the opposite doesn't give us anything. There's no variable or number there, which means we want to use our hypotenuse and our adjacent. Those are the y and the 18. So which one of your trig ratios uses hypotenuse and adjacent? Your cosine. Cosine is adjacent over hypotenuse. So we know cosine of 28, our adjacent is 18, and our hypotenuse is y. So first thing we want to do to solve this equation, cosine of 28, I get 0.883, which is equal to 18 over y. From there, just like I did on the previous one, 100 is in my denominator. Well, on this one, 100 is not in my denominator, but a y is. Y is in my denominator. So I multiplied by what was in my denominator, so I'm still going to multiply by what's in my denominator. That'll make the y's cancel. Over here, I'm also going to multiply by y. So this equation gives me, if you want to rewrite it, you can, 0.883y equals 18. And from there, we need to solve for y. So we are going to divide by 0.883. And so 18 divided by 0.883 is 20.4. So that would be your y value there. So why did I pick 3 decimal places? Well, they said up here, round to the nearest thousandth, and then round your final answers to the nearest tenth. So typically, whenever you are taking your sine of a number or cosine or tangent of a number, go to 3 decimal places there. And then your final answer, if you want to go to 2 decimal places, you can, or if you want to do just a tenth, 1 decimal place, that's fine too. So now let's look at number 2. I want you to pause the video and see if you can work through this by yourself. There are 2 different options that you can pick. You can either pick A or you can pick C. So if you pick angle C, angle C is right here. You need to label your opposite, your adjacent, and your hypotenuse. So the hypotenuse is the 15. The adjacent is this base, BC. And then your opposite is this X. So the 2 that we want to use are the opposite, because it's X, and the hypotenuse, which is the 15. So which one uses opposite and hypotenuse? The sine. So I did part B just on my figure. So now we want to write our equation. The sine of, well, the angle that we picked was C, which is a 20 degrees. So sine of 20 degrees is opposite, which is X, over hypotenuse, which is 15. So then you're going to use your calculator. The sine of 20 is 0.342. And then we multiply by what's in our denominator, which is the 15. So 15 times 0.342 should give you that X is 5.13. And again, if you said 5.1, that would be fine too. So that's if you picked angle angle C. Now let's look. There is another acute angle. We could pick angle A. So if I pick angle A, I'm going to erase this part. My hypotenuse is still the 15. My adjacent becomes the X, and the opposite is this base BC, because I'm looking at a different angle. So this is my adjacent, and this is my hypotenuse. So the one that uses adjacent and hypotenuse is cosine. So that's the one that we would want to use. Now, if you look in your figure, it doesn't give you an angle for angle A. It doesn't give you a measurement. But we know that we have a 90-degree angle and a 20-degree angle. So 180 minus 90 minus 20 leaves 70 degrees for our angle. So we could do the cosine of 70 degrees. And that equals adjacent, which is X, over hypotenuse, which is 15. And remember, in the previous lesson, we talked about the fact that these 2, the sine and the cosine of complementary acute angles, are going to be the same. So the cosine of 70, if you check, you get this same number. You get this 0.342. And so if you solve that, you end up getting the exact same thing. So it doesn't matter which angle you pick. You just have to make sure that you are very precise with labeling your opposite and your adjacent and your hypotenuse. So now let's look at the next page. I want you again, pause the video and see if you can work through this one yourself. You want to find the value of y. So choose an acute angle. So I'm going to pick the 10, that angle F, because that's the angle that they gave me. However, if you wanted to pick angle E, that it is 80 degrees, because again, those 2 angles are complementary, you absolutely could. So I'm going to pick angle F, which is 10 degrees. And then I'm going to label my hypotenuse. Where is my hypotenuse? Well, here's my right angle. What is opposite the right angle? The y, not the 12. The y is your hypotenuse. Then, once you have your hypotenuse, where is your adjacent? That's where the 12 is. The 12 is the adjacent. And then the opposite is this vertical side, DE. So the 2 that we want to use are the hypotenuse and the adjacent. So the one that is hypotenuse and adjacent is cosine. It is adjacent over hypotenuse. So I'm going to say cosine of 10 degrees equals adjacent is 12 over hypotenuse of y. So then you want to use your calculator. What is the cosine of 10? So we have 0.985 equals 12 over y. So then you're going to multiply by what's in your denominator. Y is in our denominator. We want them to cancel out. So multiply by y. And so I have 0.985y equals 12. And from there, I want to divide by 0.985. And so 12 divided by 0.985 gives me 12.18. Or you could say y equals 12.2. Either one would be fine with me. It didn't specifically tell you what to round to. If you had picked this angle E, this would be your opposite and this would be your adjacent. And so you would end up doing the sine of 80 degrees, which is equal to 12 over y. And you would still get the same answer. So it's okay to pick either one. There's no wrong way there. Now looking at number 4. Tricia did such an exceptional job creating logos that she was given the task of making a banner and representing her company at a job fair. When Tricia got to the job fair, she was relieved to see there was a ladder she could use to hang the banner. While Tricia waited for someone to help her, she leaned the 12-foot ladder against the wall behind the booth. The ladder made an angle of 75 degrees with the floor. Use the information to draw and label a right triangle to illustrate the relationship here. So, you have a ladder and it is leaned up against a wall. So here's our wall. And there's our ladder. We know this is supposed to be at a right angle. Walls are supposed to be built at a right angle. The ladder length is 12. So that means that this side is 12. And the ladder makes a 75-degree angle with the floor. So the floor is at the bottom. So this is 75-degree angle. And we are looking for, on part B, solve an equation to find how far up the wall. So we are looking for this value here. What is the wall length? So our angle is 75 degrees. The 12 is the hypotenuse. We're going to want to use it because it's the 12. What is the W in relation to this 75-degree angle? Well, it is opposite. So we're going to want to use it. So did I even have to label that this was my adjacent? No, there wasn't anything on it. So if you don't want to label it, you don't have to. So from there, am I going to be using sine, cosine, or tangent? Well, I have my opposite and my hypotenuse. Sine is opposite over hypotenuse. So I'm going to say the sine of 75 equals W, or whatever variable you picked, over 12. So then, use your calculator. The sine of 75 is 0.966. And that equals W over 12. So to solve for W, you need to multiply by 12. So you do that on both sides of your equation. And so then I get W is 11 point, you can say 5.9 or 11.6. Either one is fine with me. And so those are both in feet because that's what our units are. So we have about 11.6 feet for how far up it'll reach. Now we need to find the distance from the base of the wall to the base of the ladder. And it says using two different methods. So this is the base. I'm going to label it as a B. So on this one, two ways to do this. You can use Pythagorean theorem. You have one missing side. We now know that W is 11.6. And we know the hypotenuse is 12. So in this triangle, we could say A squared plus B squared equals C squared, where C squared is our hypotenuse, which is 12. And then we're looking for B. So I'll use 11.6 as my A. So 11.6 squared plus B squared although you could have them switched. So 11.6 squared would give you 134.56 plus b squared equals 144. So then you would need to subtract the 134 to solve for b squared. And you would get 9.44. So then what is the square root of 9.44? You should get either 0.07 or 3.1 feet. And you might get a little bit different answer if you had used 11.59 instead of 11.6 here. But you should get pretty close to that. So that's one method. The other method is using trig. So you actually have two different trig ratios that you could use here because we now have two sides. We are missing the adjacent, but we have both the opposite and the hypotenuse. So if you wanted to use cosine of 75 degrees, cosine is adjacent over hypotenuse. Is adjacent over hypotenuse. And our adjacent is b. And then our hypotenuse is 12. So then you would find what cosine of 75 is, which is 0.259. And then from there, you would multiply by 12. So 12 times 0.259 gives you 3.108, which is pretty close to what we found. 3.1. Or you could use tangent. Tangent is opposite over adjacent. So tangent of 75, opposite is 11.6, or you could say 11.59 over b. So the tangent of 75 is 3.732. And so then you multiply by b, and then you divide by the 3.732. So 11.6 divided by 3.732 gives you about 3.108, which is also 3.1 feet. So no matter how you work this, you still get the same answer. Your decimal may be a little bit off, but it's because we're using a rounded number. We rounded 11.6. So hopefully that helps you with understanding that one. Now, I don't care on your quiz and on your test. It doesn't matter if you use Pythagorean theorem or trig. You just can't go making up angles and making up side lengths to be able to use one or the other. You can only use the information that they give you or that you actually find using the correct mathematical information. So let's say you didn't want to use the 75-degree angle. You wanted to use the angle up here, which is 15 degrees. Is that allowable? Absolutely. Go for it. If you want to use that 15-degree angle, go ahead and do it. Your ratios are just going to be set up a little bit differently than mine are. So looking at the next page. Number 5, explain how to find the length of the hypotenuse without using Pythagorean theorem. Well, there's no way that we could actually use Pythagorean theorem because we don't have two side lengths. So, to find the hypotenuse, that's what we're looking for. So I'll label it as x. The 16 in relation to the 25 is the adjacent. So which one uses adjacent and hypotenuse? Cosine. So cosine of 25 degrees is 16 over x because it's adjacent over hypotenuse. So from here, cosine of 25 is 0.906 equals 16 over x. So then multiply by what's in your denominator, which is x. So I have 0.906x equals 16. And then divide by 0.906. And that gives me 17.66 or 17.7. So that's how you could find your hypotenuse without ever having to use Pythagorean theorem. Could you have used a different angle than 25? Yes. And then at that point, you would have wanted to use sine. So if you wanted to use, instead, this 65-degree angle up here, you could say the sine of 65, and then you're going to be using opposite over hypotenuse, which would be 16 over x. So now look at it, number 6. Joe says that she can find BC using the equation sine of 40 equals BC over 62. Liam says he can find BC using the equation cosine of 50 equals BC over 62. Who is correct? And explain. So on one like this, you may notice that they have the same fraction, and so you're like, oh, well, they can't both be right because they didn't use the same trig function. Well, let's look. 40 degrees. Opposite is BC here, and the hypotenuse is 62, which is sine. Sine is opposite over hypotenuse. So that one is right. Where did this 50 degrees come from? Up here is 50 degrees. And so cosine 50 degrees is adjacent. Well, this is adjacent, and this is hypotenuse. BC over 62 works there. So who is correct? They both are. Both of those work. So it doesn't matter which one you pick. You could do either one. You may have also noticed those two angles, 40 and 50, are complementary. And the sine and the cosine of complementary angles are going to be the same. So you may have noticed that right off the bat. And if so, that's fine. That could be your explanation. So now let's look at number 7, some of the practice problems. We want to find both x and y. So you got to pick. Are you going to solve for x or y first? I am, on these, only going to use the angle that they gave me, but it is perfectly acceptable to find the other angle and then use it. So if you want to find that angle, you can. It's just not going to be how I'm going to work through it. And yes, once you find one of the side lengths, you could use Pythagorean theorem to find the third side. But since we are working on our trig ratios, I'm going to encourage you to use your trig to find the sides. On your quiz or test, I don't care. Just, I would encourage you to practice using your trig ratios. So that's what I'm going to work through. So on 7, they give us 18. So I'm going to label my opposite, my adjacent, and my hypotenuse. So hypotenuse is the 25. It is across from this right angle. Then my adjacent, what is next to this 18 degrees? The x. And then what is the y? That is our opposite. So I'm looking for x first. So x is my adjacent, and I have my hypotenuse. So adjacent and hypotenuse is cosine. So the cosine of 18 is going to be x over 25. So then you can multiply by 25, and you can actually plug this whole thing into your calculator at one time to get 23.78. But you don't have to. That's up to you. So if you wanted to find cosine of 18 and then evaluate it, you could. But hopefully you're getting 23.78. For part y, that's the opposite. We have the hypotenuse. Although we could use the adjacent, I'm going to stick with the number that they gave me just in case I messed up on x, so that it doesn't also force me to mess up on y. So if you use the numbers that they gave you as much as you can, it's going to eliminate error from messing up on another one. And so maybe you wouldn't get both of them wrong if you messed up on x. So y is opposite, 25 is hypotenuse. So that means I'm going to use sine of 18. And so I have y over 25. And so if you solve that equation, you should get 7.73. So again, more specifically, if you need help, find your sine of 18, 0.309. And then you're always going to be multiplying by what's in your denominator so that they cancel. So then multiply by 25 to get that 7.73. For part B, we are looking at a 72-degree angle. So my opposite of that 72 is this x. My adjacent is this 8.5, and my hypotenuse is the y. So if I'm looking for x first, I have opposite and I know the adjacent. So opposite and adjacent are tangent. So tangent of 72 degrees is opposite over adjacent, x over 8.5. So the tangent of 72 is 3.078. Then I'm going to multiply by what is in my denominator, so 8.5. And so then I get 26.16. Then I'm going to look for the hypotenuse. And again, I'm going to use the number they already gave me, the adjacent. So hypotenuse and adjacent is cosine. So the cosine of 72 degrees, adjacent over hypotenuse. You don't have to use this one. You could use the opposite number that we just found if you would rather. That's just up to you. So the cosine of 72 is 0.309. And that equals 8.5 over y. So then multiply by y. And then we're going to need to divide by this 0.309. So then I have 8.5 divided by 0.309. And I get 27.508, so 27.51. So now let's look at C. I'm going to erase this work so that I have somewhere to do this one. So on C, my hypotenuse is y, my adjacent is x, and my opposite is 34. So I have my opposite. If I'm looking for my adjacent, that is tangent. My angle is 45 degrees. So the tangent of 45, opposite over adjacent. So the tangent of 45 is 1. So if I multiply by x, 1 times x is 34. Then I want to find my y. So that's my hypotenuse. I have my opposite and I'm looking for the hypotenuse. Opposite and hypotenuse is the sine. So the sine of 45 degrees is going to be 34 over y. So the sine of 45 is 0.707 equals 34 over y. Then you're going to multiply by y and then divide by 0.707. And so 34 divided by 0.707 gives you 48.09. Now, some of you may have noticed at the beginning, this is a 45-90 degree triangle. And we can use what we learned in a few lessons back for this triangle. These legs are the same. So this is 34 and this is 34. And then how do you find your hypotenuse? The leg times the square root of 2. So 34 times the square root of 2. And if you check 34 times the square root of 2, it's 48.083. So we rounded a little bit, so we got a little bit off on what we put, but basically the same thing. So if you notice that you have a 30-60-90 or a 45-45-90, you can revert back to the special right triangles. You don't have to do trig on those. Although if you do trig, you get the same thing. So now let's look at number 8. Jackson has the triangular garden shown in the figure. Find the perimeter and area of the garden. Be sure to check that your answers are reasonable. So we know that we have 15 feet, and that is our hypotenuse. In relation to the 22-degree angle that they gave us, this is our adjacent, and this is our opposite. So I'm going to call this the base and the height. So I need to find both. So I am going to be using, I'll find base first. I'm going to be using adjacent and hypotenuse. So that is cosine of 22 is b over 15, base over hypotenuse. So cosine of 22 is 0.927, and then you're going to multiply that by 15. And you should get about 13.9. You may want to round that 5 up to make it 13.91. Then for our opposite, we would be using opposite and hypotenuse. So sine of 22 degrees is the height opposite over hypotenuse. And if the h confuses you because you think it's hypotenuse, pick a different variable. That's fine. I was just using base and height for my variables. So then the sine of 22 is 0.375 equals h over 15. So then multiply that times 15, and you should get 5.6, and you can say 3, round to 2 decimal places if you want. So those are your side lengths. But then it wanted you to go further and find the perimeter and the area. So perimeter is just going to be add your 3 sides together. So let's look. Your 3 sides are your base, which we found to be 13.91, your height, which is 5.63, and then the hypotenuse, which they already gave you. So if we add those together, you should get approximately 34.54 feet. So that would be your perimeter. Then for your area, area is 1/2 base times height. So we found the base to be 13.91, and we found the height to be 5.63. So if you multiply and then divide by 2, or multiply by 1/2, you should get about 39.16. And units on on area are feet squared. And check and make sure those are reasonable numbers. Both of our sides were smaller than 15, but they both add up to be more than 15, so that does create a triangle. You could use Pythagorean theorem to make sure that 5.63 squared plus 13.91 squared equals 15 squared. So now let's look at 9. The longer diagonal of a rhombus measures 20 centimeters. So let's draw our rhombus. No, these quadrilaterals are not going away. So we know that our 4 sides are the same length. And they tell us the longer diagonal is 20. So this length is 20. And it has an angle that measures 100 degrees. So we want to determine the perimeter of the rhombus to the nearest tenth. So if I know that this is the longest diagonal that I just drew, I'm going to draw it a little bit differently. Well, that's not a great drawing. Let's say, I know that kind of looks like a kite, but that's a rhombus. Which of these angles is larger? Clearly this one is. This is the diagonal that's longer. So this is my diagonal that is 20, and this is a 100-degree angle. So we know in a rhombus that the diagonals bisect each other and are perpendicular. So what that means, if this diagonal was 20, this part is 10, and then these angles were cut in half. So if this whole thing is 100, this angle is 50. So I'm going to redraw just that figure, that one right triangle. 50-degree angle, and the height was 10. Then I need to find the perimeter of the rhombus. Well, if I find this side length, I multiply it by 4 because all of the sides are the same, and that gives me the perimeter. So how can I find that length using trig? Well, I know that the x is my hypotenuse, and the 10 is opposite the 50-degree angle that they gave us. So I'm going to use the sine. So the sine of 50 degrees is 10 over x. If you want to leave it in terms of sign, you can. X times the sine of 50 equals 10. And then you can divide by the sine of 50. So that in your calculator, you can actually plug in 10 divided by sine of 50. You don't have to do it that way, but if you do, it works the same way. You get 13.05. So then, take that number and multiply it by 4. And so you should get about 52.2 centimeters for your perimeter. So hopefully that helps you with understanding how to use your trig ratios. We're going to continue looking at trig in the next lesson as well. So you really need to make sure that you learn your trig ratios.